We are Scientific Club Bekker Team, a group of passionate students from Faculty of Automotive and Construction Machinery Engineering from Warsaw University of Technology. Our rover MB198 is much more than a vehicle. It's research, it's learning and teaching, it's history and friendship. Our team's name reflects our inspiration and role model, Mieczysław Bekker, a distinguished Polish engineer and scientist. It represents who we are, curious minds driven by creativity, collaboration, and the love for science.
Our team is divided into several key sections: mechanics, electronics, autonomy, and publicity. We are guided by our supervisor, PhD Damian Markuszewski, who supports us in technical and financial matters. Mr. Damian also handles administrative tasks and manages our external collaborations. Our president, Christian Jakubiak, coordinates the team's work, assigns tasks, and tracks progress. He is highly skilled in electronics and low-level programming. He also enjoys working on vision systems. Our vice president, Paweł Szymański, creates and manages technical documentation and oversees quality. He is mechanical engineer and former student council member. Our treasurer, Bartłomiej Majewski, is in charge of managing our budget and seeking out funding opportunities. He also works on drivetrain and wheel traction systems and is best at representing our team at public events. Our technical lead, Aleksandra Grzybek, a former two-term president, now focuses on project's technical details and mentoring new members. She develops advanced algorithms and manages databases for entire rover. And finally, our control station designer, Jakub Jedliński, planned and built our control station from scratch and now takes care of its maintenance. He also developed the wireless communication system that we use. Bekker team members are passionate about new technologies, professional programming, and are enthusiastic about DIY projects. At the turn of March 2020, the club was reactivated with new goals and fresh team. Since then, some of those members have already graduated. During their time, they planned the rover mechanics with innovative design, including calculations, modeling, and building the rover itself. Their work laid the foundation for our further development. Today, we proudly work upon their legacy, combining experience with new ideas.
As a student research group, we are enthusiastic about participating in the upcoming competition because we see it as a unique opportunity to fulfill several important goals that define our mission. Primarily, we are passionate about popularizing science. Our group actively participates in various events as exhibitors, where we engage with the public and share the excitement of scientific discoveries. We also organize youth workshops aimed at inspiring the next generation of scientists and engineers. Participation in this competition would allow us to continue these efforts on a wider scale and reach new audiences. Secondly, we believe in combining science with fun. For us, research is not just about theory. It's also about gaining practical experience, developing hands-on skills, and conducting our own scientific projects. At the same time, teamwork helps us build meaningful interpersonal relationships and a strong sense of community. Competitions like this one are a great way to learn, grow, and enjoy the collaborative process. Finally, we want to prove ourselves. These competitions provide a valuable opportunity to evaluate our performance in a challenging and motivating environment. It's a chance to see how our ideas compare to other passionate teams, receive feedback, and push ourselves to improve. For all these reasons, we are really excited to participate in the competition, to share what we do, learn from others, and celebrate science.
Our rover is designed with an emphasis on lightweight construction, durability, and advanced autonomous capabilities. By integrating composite materials, cutting-edge electronics, and robust mechanical solutions, we have created a highly functional and adaptable system. The vehicle is capable of navigating challenging terrain, performing precise manipulation, and maintaining reliable communication with the control station. The frame of the rover is made using sandwich technology, a combination of carbon fiber filled with a printed structure honeycomb, 3D printed with PLA and polyurethane film. The rims are a combination of a rim 3D printed in PLA material and a reinforcing band made of carbon fiber. Such a material bonding technology allows us to obtain structural components and parts with a very good weight to strength ratio. Our manipulator is capable of lifting up to 5 kilograms of weight and is also built from thin-walled aluminum profiles. The bottom part and the base were laser cut. The upper element is a hand-finished channel profile. Rotation of subsequent elements are carried out by servo motors and a linear actuator with encoder. The servo motors allow precise positioning and high torque. The drill mechanism consists of two motors. One is responsible for driving the drill and comes from an electric scooter, the other for advancing the carriage using a rack and pinion bar. The system has been tested and a borehole depth of 20 centimeters has been achieved. The drill rig has two proprietary interchangeable drills. We use a wireless Wi-Fi connection and TCP/IP protocol to communicate between the rover and the control station. To ensure a good connection, we use the microtic router, which has many network configuration options. The rover's onboard computer is Jetson Xavier AGX, while the component control units are two STM32 microcontrollers. The wired connection between them is provided by controller area network and I2C communication protocols. Those two microcontrollers and the protocols are divided by steering or signal generating and measurement acquisition.
Here we have our control station. That is the device that serves purpose to control our rover. So the first step after initializing the app is to select IP of the rover. It is fixed, but we still have that window to properly initialize. We are connected, and that's our GUI of the control station. The control of the rover is done by devices on the main panel, buttons, joysticks, and side pod. The side pod serves to regulate the speed of the wheels. And let's give it a try. Let's go forward, backwards, left, and right. Right, we can also regulate the angle of the turn by manipulating those buttons. Okay, we also have, we are able to control devices on the rover. We have that second panel that controls manipulators, grippers, and drilling. You're choosing what do you want to move by clicking the button. You activate different sliders. Manipulators, gripper, and drill.